Hi Year 7, welcome to today's lesson. We're going to be looking at data representation again. So it's your choice today. You can watch the whole video and then access the lesson on the assignment on Teams, or you can have the assignment open and watch the video and pause it to complete the different exercises. I'll indicate when would be a good time to pause as we go through. What we're going to do today then is we're going to recap on how to convert binary to denary and also learn how to convert denary to binary. Then we're going to hopefully understand how we sometimes will encode text in different ways, and then also how we can use binary then to represent text. So, quick recap then on how we convert binary to denary data. Now, if you remember, with the binary data, we use our place values, and you'll see that I've got those just written at the top of the slide for you to refer to. So, let's see what we do then. So let's take a binary number, and in this case we have it here, 011001. Now, step one in working out what the number is, we would first of all need to work out, well, what are the place values? So what is each of those numbers worth? So we use those place values that we have written across the top, and I'm just going to write those. I'm just going to separate out those binary digits, those zeros and ones, and put the place values over the top. So notice how we always start with the 1 on the right hand side. It's important to get that in the right place. So we have a 6-bit binary number because we have 6 bits here. Each of these zeros and ones we refer to as a bit. So then how do we work out what this number is? Well, if you remember, each of the ones means that that is one lot of that place values. So we have a 1 under the 16 here. Now that is worth 16, and we have a 1 under the 8, and that 1 is worth 8. So we have one lot of 16, add 8, add one lot of 1 equals 25. So 011001 as a binary number is equal to 25. Now, converting denary numbers into binary numbers is similar in that we use exactly the same place values. So notice up at the top of the slide I still have those headings, the place values written for me. So let's take a number 45. So in order to work out what the binary number is for 45, is we need to work out which of these numbers, when added together, what combination will add up to 45. Now you could do trial and error. You could just, sometimes it might be obvious which 2, maybe 3 numbers you could add together to make your number. But it isn't always obvious, so I'm going to show you the slightly longer way on how to do this. So again, just like before, we're going to write down our place values. Now 45, because it is smaller than 64, we know we're not going to have a 64, so I'm only going to use the place values from 32. So it's worth drawing your table like this. Now, the first, we're going to start on the left over here with 32 because this is the biggest number. So we're going to start off trying to fit in the biggest numbers that we can into the number 45. So 32 will fit in 45, so we're going to have one of those. Okay, so we put a 1 under the 32. Now if we take 32 away from 45, we have 13 left over. So that won't fit 16, so we've got no 16s, but we will be able to fit 8 into 13. 13 take away 8, we have 5 left over. So with one lot of 32 and one lot of 8 in 45, we have 5 remaining. Now, at a glance, you can probably tell that to make 5, we can use a 4 and a 1. So we have one lot of 4 and then we have 1 remaining. So our binary number for 45 is 101101. Okay. Now, if you still need some help in doing the binary conversions or the denary conversions, you can go back to the Wellington Computing Department YouTube channel, and I'll make sure that there's a link to that in the Teams assignment, so you can always watch that again if needs be, or just watch this part of the video again. Now might be a good time if you want to pause the video and go to the Teams assignment. The first page has 20 questions for you to answer and practice your binary to denary conversions and your denary to binary conversions too. So if you're going to pause the video, pause it now, otherwise we'll go on to the next part. So the next part of the lesson, we are looking at trying to understand how we sometimes encode text in different ways. On the screen in front of you, you will hopefully recognise the Morse code. Now last lesson we looked at the Morse code, but we looked at how we represent numbers using Morse code. We can also represent letters of the alphabet with Morse code. At the bottom of the screen you'll notice I have a message written in Morse code. Can you see what that message is? So we would have a look, first of all, for 3 dots. And you work your way through, and hopefully you can see that the letter S is 3 dots. So the first part of the message is S. And we're also going to repeat that at the end because we can see we've got 3 dots again. The middle letter is made up of 3 dashes. So we look through and we find the letter O has 3 dashes. So that is the message SOS, usually used to send help. Another way we would sometimes encode text is using this cipher. Now you might recognise this cipher, some of you may have done it before. It's called the pig pen cipher. Now how does it work? Well, you can use a message, or rather you can use it to encode a message. It apparently started with ancient Hebrew rabbis, and they also there's also some evidence to suggest that the Knights Templar may have used it during the Christian Crusades, and they used it to encode their messages. Now how does it work? Well, you'll see that we've got some symbols. Now those symbols can be used to work out what letters of the alphabet they represent. So you would draw these 4 grids. The 2 grids on the side, on the right hand side, have dots on them, and we can work out that if we look here, this first letter with the arrow pointing that way with a dot, that represents this shape here because there's a dot, which means this first letter is the letter X. If you want to challenge yourself, pause the video now and see if you can work out the rest of the message. Okay, so the answer is X marks the spot. And hopefully you can see how the different letters, so for example the letter R here, which has a dot in it, we can see that shape here with a dot in, and that's the letter R. And that is called the pig pen cipher. Again, if you are completing your classwork as you go along, now's a good time to pause the video to complete the next 2 pages of your work in your assignment. So there are 5 questions to answer on the Morse code and 3 questions to answer on the pig pen cipher. Last part of today's lesson. So why have we looked at representing text, encoding text using Morse code and pig pen? Well, because in a similar way we can use the binary code to encode the letters of the alphabet. Now you can see here using 7 bits, so that is 7 zeros and ones, we can code the letters of the alphabet A to Z. Now it's very hard to learn all of those, and you would never really be expected to learn them, but each one goes up in number. So it's difficult to see on here, but what I'm going to do is I'm going to show you this in a slightly different way that you might find easier to work out. So early computer scientists came up with a coding system to convert letters into binary, and it uses 7 bits for every letter. So the first thing that you're going to do is you need to find it in the table. So you need to find your letter, and the first 3 bits are in the column heading and the last 4 bits are in the row heading. So for the letter H, as you can see on the screen here, the letter H, the first 3 bits up here are 100, and that's written there, and the last 4 bits is 1000, 1000, and that is the second half. So this here is the full binary value for the letter H. So let's take another example. What if I wanted the letter S? So over here we've got the letter S. So the first 3 bits is 101. So for the letter S, we would have 1, 0, 1, and then we would look across to the last 4 bits, which would be 0, 0, 1, 1. Okay. Now if we want to work it out the other way and take a binary value and turn that into a letter, again we're going to split that binary number into 3 bits and 4 bits. So you can see the example here, 1010111 becomes 101 and 0111. So when we look over here, we find the 101, so we're looking on this column. We can see the arrow going down here, and then the last 4 bits, 0111, and we know that it is the letter W, and that's our answer there. Your task next is going to now be to work out, using this method, what the names are of these 3 famous computer scientists. So using that method we've just gone through, I'd like you to work out, so the answer to question 1 should be a 3-letter name, the answer to question 2 should be a 3-letter name, and the answer to question 3 will be a 4-letter name. You don't have to pause it and work this out from here. This does show up on the classwork on your Teams assignment. So here's the full sheet that you will look at in Teams. You can put your answers in the boxes as shown, and then there are some additional ones to work out. And then one of the questions, question 5, it's showing up there. Write feed me using this system in binary. So you're going to write out those binary numbers. Now that's not the last task, although for some of you it might be that you've spent 2 hours now on your classwork, in which case please don't feel that you have to complete the next task. However, if you've completed this early, I'd like you to look at this last task. So the last task is a final challenge. Now you can see here I've done 2 examples. So using what you've learnt about representing text using binary today, I'd like you to try and get a bit creative to show how you've understood. You could try Lego, any sort of food, coloured paper, maybe something from the garden. Use your imagination and take a picture. So you can see I've got 2 examples here. The first one I've used Lego. Now if you're really eagle-eyed, you'll notice that I've used 8 bits to represent my letter with the Lego. I've used white to represent a 0 and black represents a 1. And it just so happened that I had the bit of Lego that I had to connect my blocks on just fitted on 8, so that's why I've used 8 there, but you don't count that first one there anyway, you can knock that off. Okay, so that represents this binary value, and if you've been on our Instagram page over the weekend, then you will have noticed that this represents the letter Z. So there's an example of what you could do to show your understanding, but you don't have to use Lego. You could really use anything. You could use 2 different types of leaves from the garden. If you've got different types of sweets or different coloured sweets, you could use those. Now you can do 1 letter, or as you can see on this second example, I've actually done 3 letters here. Now those 3 letters make up a name. In this case I've only used 7 hammer beads per letter. So we've got 1, 2, 3, 4, 5, 6, 7. So that would be 1 letter there, and then the second letter here, and then the 3rd letter, and that spells the name of a friend who I could give that friendship bracelet to. You could make jewellery that spells all sorts of things using binary, but if you don't have beads, you can make beads from different coloured paper. Whatever you want. As I say, you could get creative, take a photo and upload it either to your Teams or to the class charts, and I can upload some of the nice ones, or as many as I can get, onto our Instagram page, all your hard work, and get, show that off to everybody. So that's it. I hope that you have understood that. Remember, I will be online for part of today's lesson during your time slot. If you have any questions, you can always write them in the chat, or as I say, log on to the live bit if you need me. Okay, thank you very much.